All right, we are in period 2 with my AP Stats students from room 101 in H-Town, talking about the King, LeBron James. Jacob, can you read for us number 3?
The 2007 LeBron James made 31.5% of 113 shots made in 359. During the playoffs that year, LeBron shot 73.
All right, part A. Thank you, Jacob. Part A says, explain how this is an example of a Bernoulli trial. What's the first thing we should check? Success failure. Well, what do we think? Very good. Made 3-pointers is a success, and missed 3-pointers is a failure. So that seems like we're good so far. What's the second thing that we check? We check our P, all right? We check that we have a constant probability of success, or P. What is P? 0.315. Do we think this is constant?
Yes. It's the average.
Exactly right, Jacob. Every time he takes another shot, it changes. But if we're getting this number from an entire season, right, 359 shot attempts, if he takes a 360th shot attempt, whether he makes or misses, how much is that going to change? Little, right? It will change, but not very much. So for our purposes, we're going to say constant enough. Good enough. Number 3. What's the last thing we think about? Independent trials. What do you guys think about independent trials in this context?
Yes.
Yeah, we think they're independent. If he makes one, that's going to have no bearing on whether he makes or misses the next one? No? Yes? Yeah.
Wait.
My question is, if LeBron James comes up and he makes a 3-pointer, and then a minute later he comes down and shoots another one, do you think that the next shot is going to go in or not based on what he did on the previous one?
No, they don't.
They don't. They don't.
Yeah.
And that's because of my favorite law, the law of large numbers. Big numbers is fine. I accept. The law, if you say the law of big numbers, we know what you're talking about, right? People will say it's large, but that's fine. Big is fine. Law of large numbers. Okay, so we're good with independent trials. If he makes or misses a shot, it has no bearing on how he does on the next attempt. Ooh, injuries? Like if he's playing injured? Yeah, I mean, that's obviously something that we have to talk about, but does it say anything about that he played injured this season?
No,
He got pushed. You know how big LeBron James is? He gets pushed, it's like he got bit by a fly. Okay? He's like 6'8", 250. All right? He's a large man. He's not moving if you try to push him. Okay. 6'2". Much taller and a little bigger. Uh-huh. He's 6'8". 6'4", or 6'5", sorry. He says 6'6", but he's 6'5". What? I asked him. He's like, I'm 6'6". Are you really? He's like, no, I'm 6'5". Okay. What is we all do. When I was in high school playing basketball, I was 6'3", with shoes. What is the expected number of 3-pointers that LeBron makes during the playoffs? So we're talking about the entire playoffs. All right? How many shots did he take in the playoffs that year? 70. So during the playoffs, he shot 73 pointers. Now, this is important to understand this distinction because it's going to determine the formulas and the model you use. Are we waiting to see him and how many shots it takes for him to make one? Or are they telling us the number of successes out of a certain number of trials?
Number of successes.
They're telling us this is a binomial model. So I get students that do this, and they use mu equals 1 over p. But that's what you would use if this was geometric. How many shots do we expect him to take until he makes his first one, or need to take to make one? That's expected value for geometric. But this is binomial. So the formula for mu is n times p.
We even use mu even though it's like real data.
I'm making a model, so yeah. But you could convince me. I'm making a model. What is the number of shots that he takes in the playoffs? 70, because we're basically guessing here. What's his probability of success that we're using for this playoff run?
0.315.
Very good. So how many, before he even starts game 1 of the Eastern Conference quarterfinals in 2007-2008, how many threes do I expect him to make for the entire playoffs if he takes 70? 22.05 3-pointers.
We're still with the Heat, right?
I think he might have been with the Cavs in 2007-2008, but I could be wrong. Like, he could have been in the Heat. I think he was still, I hadn't taken his talents to South Beach yet. Any questions on B? Let's move to C. Okay, letter C. What is the standard deviation for the number of 3-pointers that LeBron made during the 2008 playoffs? Still the binomial model, same model. And we're going to use the formula for standard deviation is the square root of n times p times q. I've always wanted to make like a radio channel or a company and call it NDQ. Just for the stats people out there.
Number of
So we could use that.
Just for fun.
make a podcast.
Okay.
That's cheaper.
We already know N and P. We just use them. 70 shots. Probability of success, 0.315. What's Q? So 22.05 is the number we expect him to make in the playoffs. What's his probability of failure in the playoffs? 0.685. It's always 1 minus the probability of success. So a mental check, if you're doing this and you're not just like zoned out, the mental check is these two probabilities should add to 1. If they don't, then I know something is incorrect. Okay? So what is the standard deviation? $3.89 right here? 3.89?
Yeah.
Okay. Don't forget your units. This is still 3-pointers. Any questions on finding the standard deviation? Pretty good? Okay. This is pre-Steph Curry, by the way. 2008, Steph Curry was in college. What? I don't know how old Steph Curry is. Younger than me. But not as tall. He's 6'1". Ha! He's so short. Okay. This is where it gets fun. All right? I know many of you are thinking I've been having fun, so I'm not sure what you're talking about. But this is what it really picks up. Okay? Read letter D for us, Suzette.
LeBron actually made 18 3-pointers during the playoffs again. The media criticized him for not performing up to his usual standards. Are his 18 3-pointers unusual considering his regular season 3-point goal percentage of 31%?
Right? And this is pre-fake news, right? Before Donald Trump invented that phrase. All right? So basically I'm asking, did the media unfairly criticize LeBron James for the reason that the Cavs lost in the playoffs? Let's find out. We just spent the first part of this problem talking about the binomial model. But I told you that we can actually get it to become the normal model if we check a condition. Do you know that condition?
10%.
Not the 10% condition. I don't know what this means. Okay. The success-failure condition. Let's change the color for that one because it's so important. Exactly. If we expect 10 or more successes and 10 or more failures, our sample size of 70 then is large enough that we can say bye-bye binomial and say hello normal model. All right, that's what we're hoping for. So we check n times p and n times q. Guys, we've already done n times p. What is n times p? 22.05. So what is n times q? What is 70 times 0.685?
Yeah.
47.95. Another check. Some of your brains have already seen this. If you were to add these two numbers together, you would get 70. All right, so that's always another check you can do. It should be your n. Okay, because remember, we only have two options. If you tell me there's this many successes, well, then subtracting from the total to get the failures. Okay, so you can always do it that way. Look at those two numbers. Look at just 22.05. Is that 10 or more? Yes. Look at 47.95. Is that 10 or higher? It is. So both of those numbers are 10 or above, which means our sample size is large enough that we can actually use the normal model.
What if it's not?
You can't. Then you continue to use binomial. You can still use binomial. But now I'm going to take those numbers you just calculated for the mean and the standard deviation and write it with a capital N for normal, 22.05, comma, 3.89. So we're saying, now let's use this as a normal model. And the moment I do that, I'm thinking, guys, it's time for a curve. It wasn't my best, but not my worst. What is smack dab in the middle of that curve? 22.05. Now, do you remember what we stated about the normal model and things being unusual? Three what?
Standard deviation.
3 standard deviations in which direction?
Left or right.
Left or right, both directions. Okay, so let's go both directions just for funsies. Let's go one to the right. So you take one to the right, 22.05, and add 3.89. 25.99? 94? No? Did you write a 9 or did you write a 4?
9.
It's a 4. I mean, it doesn't matter, but I'm just making sure you know it's 4. Okay. Add another 3.89. You need two numbers after the decimal. Thank you. And the last one. Did you add 3.9? That's probably what you did.
No.
Yeah?
3.89.
Huh. Oh, but you added to the previous numbers, which are different. That's fine. Okay. You're good. All right. So let's just say right now, looking at going above, so 3 standard deviations to the right, can you tell me a number right now out of 73 pointers that LeBron James makes in those playoffs that you would consider unusual in the upper direction?
34.
34. Another one.
54.
55. Another one. 70, right? All of them. All All right, somebody said in the other class, 110. Well, no, he took 70. So if he's making 110, only took 70, we got something's going on. Okay? Everybody good? Let's go the other way. So take 22.05 and subtract 3.89. 18.16? Okay.
14.7.
There we go. Last one. 10.38. All right, and so now we ask the question. He made how many? For real, how many did he make? He made 18. So was the media too harsh?
Yes.
Or were they harsh enough? Or should have been harsher?
Too hard.
Should have been harsher. Wow, LeBron hater. When I look at 18, 18 is right here. So just past one standard deviation below the mean. Just past one standard deviation? Is that unusual?
No.
And we said it had to get to past 3. We're not even to the second yet. So the media is unfairly criticizing LeBron James's 3-point shooting and how they lost that round. Yeah.
Why is it like sports? Like Stephen A. Smith, all of these
You know why? Do you want to know why they don't use? They use math, they use statistics, but if this rolled up to somebody's desk and they're writing a piece or they're going to talk about it on their show, like Stephen A. Smith, we don't have to badmouth him. I mean, whatever if you want. But if it rolled up to the desk of someone who's about to write something or go into a show, and this disproves their point, they're not going to use it. Right?
For the money?
Well, because if their point is saying that LeBron is the reason that this team lost that round, they're not going to use data that says it's not his fault. Right?
We should create a sports channel.
Anytime you read a statistic or listen and hear a statistic, you should immediately be skeptical. Immediately. All right? And try to find your own research and own information. Because most of the time, if you're reading something, they're picking and choosing the data that supports their decision.
Like bias?
Not bias. They are basically, if their job is to convince you of something, they're only going to use points that help them do that. Okay? Everybody good? Marcelo.
What was a binomial model? What would we do?
For a binomial model?
If it was under 10.
Well, so the only reason we got that 10 number is because we said it was normal. We wouldn't do any of this work if you'd only taken like 25 3-pointers. Whatever the number would be, that's too low. All right, we wouldn't even do this work. All right, we need enough of a sample, a big enough sample, to make this worthwhile. Right? And so what I would argue, Jacob, with all these, if you're talking about sports people using data, if you're interested in that, start following on social media a organization called 538. All right. So you're interested in statistics as a we'll just use the bias, unbiased way of looking at things. 538. They publish reports, sports, politics, anything that uses data to explain things to you.
I'm a listener.
538. Highly recommended. All right. That's all we got today in stats. Thanks for listening. And Tanya's going to be watching this later. Enjoy, Tanya. Shout out.